This is Algebra 2 with Trig. We're working on 5A.2b. It's the second day of 5A.2, the second day, so we're going to call it point 2b. This time we're simplifying our radicals, but we're going to use variables. Variables can be positive, they can be negative, they might be zero. So sometimes absolute values are needed around an expression. But we're going to consider all of our variables to be positive, so we're not dealing with any absolute values. So we're working with the fourth root. The fourth root is looking for 4 of a kind. So 625 is actually 5 to the 4th power. There's 4 5s that multiply together to make 625. And I have z to the 3rd, z to the 3rd, z to the 3rd, and z to the 3rd. I have 4 of a kind of z to the 3rd. So I have 5z cubed. No, I have 5z to the 4th. Sorry. Because I pulled out one set. I did this one wrong again. I need groups of 4. I had that in my head backwards. I have groups of 4. So I have 4 of a kind, 4 of a kind, and 4 of a kind. So I have z cubed. There's 1 set, 2 sets, 3 sets of 4 of a kind of the z's. In this one here, you know that the exponent of the 32 is a 1. So we're going to distribute our exponent in and multiply all these exponents by 1/5. So 32 to the 1/5, you could look on your power table, and if you look under the 5th for 32, you'll see that that's the number 2. Because 2 times 2 times 2 times 2 times 2 makes 32. This is m to the 1st power and n to the 6th power. Here we can consider this to be the 6th root of r to the 6th, which of course is r. And this is the 6th root of s to the 18th power. There are 3 different sets of s's in there, 6 of it at a time. So there are 3 sets that you bring out. 6 goes into 18 3 times. 6 goes into 6 1 time. Now, this type looks very complicated. I would suggest to try to break it up into separate pieces. This is 8 over 12. You're using the constant numbers. K to the 2nd over k to the 3 halves. There's only one type of m in there. So there's nothing on bottom, so you can call it 1 if you want. And it's d to the 2/3 minus, because we subtract when we bring up our value, we subtract the exponent. So we're actually going to call it a plus. So the 8 over 12, 4 goes into 8 twice, 4 goes into 12 3 times. when you have the same base, we are going to subtract exponents. Nothing to do with the m. And here we're going to say d to the 2/3 plus 1. So that gives us 2/3. To subtract fractions, we need common denominators. So we know our common denominator has to be a 2. So this is 3/2, but this fraction has to equal the original 2. So what number divided by 2 is going to make 2? 4 divided by 2 makes 2. M doesn't change at all. And with the D, we need common denominators. So several people get confused by this. Here we have 2/3. And we're going to add 1 to it. But to add fractions, we need common denominators. So we need a number that has a denominator of 3, so it's common. So we have to have a 3 in this spot. That's a value of 1 to be added to the 2/3. So we're going to get 2/3 k to the 1/2, m to the 2/5, d to the 5/3. There could be some more simplifying with that, but we'll leave it in that format. So here we have 56 divided by 7. We have A1 minus 5/6. We have B to the 3/4. And we're going to bring the C up to the top as a positive exponent. 56 divided by 7 is 8. 6 over 6 minus 5 over 6. So that's going to give us 8, a to the 1/6, b to the 3/4, and c to the 3rd. For letter F, there's multiple ways for us to think about it. We're doing cube roots, so we're looking for 3 of a kind. There is not 3 of a kind in 6. But you do have 3 of a kind of the x's, and you have an extra x. There is 3 of a kind in the y's, and there are lots of 3 of a kinds So that's one way to think about it. It's a little elementary way to kind of think about breaking it all down. But it does help you visualize exactly what you're looking for. There's nothing you can do with the 6. There's not 3 of a kind that makes 6. You have 3 x's, so you can pull out an x. You have 3 y's. You have a y, another y, and another y, so you have y cubed. 1z, 2z, 3z, 4 different z's. So this is the cubed root of 6xz squared. Everything else that's left in there. We could also think about, how does 3 go into 4? 3 goes into 4 once, so you bring one of them out, you have one of them left over. 3 goes into 9 3 times with none left over. And 3 goes into 14 4 times with 2 left over. That would be a little quicker way to kind of work your way through it. So when we're here, notice the variables are different. So we're actually going to think about them as 2 different radicals. So one way to think about it is 7 goes into 12 one time. So you are going to have a p that comes out. There would be 5 of them left over. You would pull out your group of 7 of them, and there would be 5 of them left over. 7 goes into 14 2 times. So you have 2 groups that come out, and there's none of them left over. So our last examples. Here notice that we have the cube root of u, we have the cube root of u. So you could almost call that 18x minus 11x. You have 18 of something minus 11 of the same something, so you can call this 7 of that something. And luckily enough, when you look here, these are exactly the same. So I have 15 of this, I have 8 of this, so I have 23 of this. But when we look at our last example, you could say that we have 10x and we have, this is an s, y. This is different than that. You cannot combine them. But can we convert what's inside there? I notice that we're doing the 4th root, but I have 7 of a kind inside of it. So if I have 7 of a kind that's inside of it, I can bring out a group of 4 of them. That leaves me my 5. And if I brought out 4 of them as an S, I now have 3 left inside. I have my S that's on the outside. I'm doing the 4th root, 80. 80 can be broken down into 16 times 5. I like 16 because 16 is a 4th root. Fourth root of 16 is 2. I also have s cubed. I don't have 4 of a kind there. So I have 10s, the 4th root of 5s cubed, minus the 4th root of 16 is 2, times my s, but there's nothing I can do with the 5 or the s cubed. So I was working to get my, it's called the radicand, the value inside the radical, the same. 10s minus 2s is 8s and this is the fourth root of 5s cubed.